Good morning everyone. I Nivedita Tiwari going to present my today's session on the subject computer system architecture. The content of the sessions are the following. First of all, I have discussed what is the instruction. So basically instruction are the fundamental unit of work that specify the two things. First one is the opcode and second thing is the operand. Now what is the opcode? Basically opcode is the different operation to be performed on the various operands, and operands, the second thing is are the operands. These operands basically are the data or locations to be used for that performing that operations, and these data or location may be presented on any kind of register or and any memory location. For example, if the given expression is the a plus b, on this expression the opcode and operand values are the a and b are the operand values on which the opcode is performed, that is the add operation. So this type of expressions and are given to the computer to performing any type of instructions, on which two basic things are will be available. One is the opcode and second one is the operand. So and b are the two values on which we perform our operations, and these operand values may be available in your memory or in the registers, and on these operand values we are performing the different kinds of operations, and that operation will be stored in the form of opcode. Basically opcode is the operation to be performed. And if we define our computer instructions, then these are a set of machine language instruction that particular processor or CPU understand and then execute that instructions. Next, the instruction formats on which your instruction is stored in your computer memory. Basically a computer perform different types of tasks in the form of instruction, and this instruction that we provide to our computer is basically we basically provide this instruction in the specific format, and this specific format of the instruction is divided into 3 fields. These fields are available in this block diagram. The main field of the instruction format is the operation code field. Basically it this field specify the operation to be performed. The second field is the address field, or we can say that the operand itself is available on this address field. So the address field contains the location of the operand, that is or that is the register address or the any memory locations. The third and most important field of the instruction format is the mode field. Basically this field specify how the operand will be located either in the memory or any register. So this is the basic instruction format for any computer system on which we provide any kind of instruction with the help of this format. Next, The main and most important field of the instruction format is the mode field. Basically, if we provide any instruction to the computer system, it specifies some size. So here you can see the instruction format. This instruction format is basically of the 16-bit instruction format. So we define these 16-bit values on the upper side of the format, starting from the 0 to 15. So here in this instruction format, the three fields are available of the instruction, on which the address will contain the 12-bit address, the opcode will contain the 3-bit opcode, and the last and important field, the mode bit, that is represented by the letter I, capital I, and it contains the 1 bit of the instruction. So here mode bit field has basically two values. The computer instructions are basically operated on the binary numbers. So here two values are available for this I value, that is 0 or 1. So when the I represents the 0, the it represents the direct address of the memory. The concept of the direct memory, and whenever the mode bit field represents the value 1, that means it represents the indirect address. So you can see the block diagram of the direct and indirect address in figure B and figure C. So whenever the bit value of I is equal to 0, then the memory refers the direct address. The direct address in the address field means that memory refers the this address value refers to the memory directly. So here two things you have to observe, that is the instruction in the instruction field I is equal to the 0, and the address field value is equal to the 457, and the opcode value is the add. So this instruction is stored in the memory, and the value of this address field is directly referred to some memory location. So in that case, the value of the direct address is equal to 457, that is available in your memory in instruction address field, and its corresponding value is the operand value. In case of indirect address, the instruction the mode bit field having the value 1, and the address field value available in the instruction here is 300. So in case of indirect address, at this location some value is available that again refers to some other memory locations. So in case of indirect address, value of that address will be 1350, that is available at the memory locations value available in the instruction. So here indirectly refers to the memory when we talk about the indirect address. So if we analyze these two concepts here, so you can see that in case of direct address, the memory reference will be one time, but in case of indirect address, the memory reference will be 2 times. So basically the two main differences are there. The mode field, in case of direct address, the value of mode bit is equal to 0, and its address value will be 457. And in case of indirect memory address, the mode bit field value will be 1, and the out the address value will be 1350. So this is the concept of direct and indirect address that will be useful to find out the operand value from the memory. On the basis of these concepts, we are moving towards the